Okie dokie, guys, this is going to be our last one, or hopefully last video, unless I start hacking up a lung again. Hopefully I do not. Okay, so I'm gonna try to make this quick-ish. So looking at number 12, I'm gonna make a really rough draft of these graphs. Something like that. I know this looks nothing like it. Then we have something like that. Sure. Okay. This is y equals g of x. And this is y equals r of x. Okay, so I'm going to go over an example or two of these. Hopefully after that you get the basic concepts and you can do it on your own. So let's check r of g of 2. So first we want to find out what g of 2 is. So 2 is our input, which is x, right? So we say, okay, when the x value is 2, what is g of 2? So let's take a look. So g of 2 is approximately 5, because when x is 2, y is 5, and y is g of x. So that means we can replace this with 5, right? So now instead of looking for our g of 2, we can be a little more specific and say r of 5. So then same idea, 2, 3, 4, 5. I know that's really off, but so here is the point 5, and that's 2. Okay, and that'll be 2. So we're looking at the input 5, but because we're looking at the function r, we're looking for the point on this red graph, not this blue graph. Here we were looking for the output when x is 2 of the function g, so we look at the g function graph, which is in blue. So we don't stop here, right? We stop here. Okay. Let's see. Okay, so now we're looking for g of r of 1. So first we're going to find r of 1. X is 1. R of 1 is going to be equal to, let's see, we're looking at the r graph, so we're looking at the red one. The point is 1, 1. So when x is 1, y is 1 in the r of x function. So we can replace this with 1, so now we're looking for g of 1. So when x is 1, what is the g function? Or what is the output of the g function? And you can see on the graph it's around like 2.5. Okay? So the output of the g function when the input is 1 is 2.5. Okay? So same idea for the other two parts of part A. Okay. So the next part says, as x increases from 4 to 6, the value of g of r x increases, or blank, from what to what. So we're looking at the interval 4 to 6. This is initial x, and this is final x. So we want to know how the value of g of r of x changes. So that means we need to find out our initial one, our initial output. So g of our initial input, which is 4. Okay. So let's find R4 first. What is the output of the R function when the input is 4? If we look at our graph, we have the point 4, 3. So it's something around here, right? 4, 3. So this is 3. So now we're going to look for g of 3. So the output of the g function when the input, or x, is 3 is going to be, let's say, 5.3, 5.3, something like that. You don't need to be, as long as you're close. She's not going to be super picky about what decimal value you choose. Okay, yeah, so we did 3, and it's around here somewhere. Okay, so we figured out this value. Now we need to find our final output value, g of r over final input, which is 6. R of 6, what is the value of r at the input 6? And you'll see the point 6, 1. So the output of r is 1 when the input is 6. So now we're looking for g of 1. So same thing, what is the output of the g function, the blue function, when x is 1? We say 1, we get the point, again, 1.25, or the point 1, x, 2.5, y. So this is our initial output, this is our final. So we notice that it's going down, it's decreasing. So we would say on the question, sorry guys, I'm pulling this up on my laptop. Okay, as x increases from 4 to 6, the value of g of r of x, right, these values, are they going up or are they going down? They're going down, right? We've decreased. So decreases from initial 5.3 to final 2.5. Okay? And that's going to be the same for -2 to -3. Same approach, different answers, right? So find g of r of -2, find g of r of -3, just figure out if it goes up or down, and then just plug in those numbers in the blanks. Okie dokie. So 13, we have x and f of x. We have t and g of t. I'm not going to write down all of those right now. But so let's say we want to find f of -2, right? So the input to f is our x. So when x is -2, if we look on the table, we'll see that -2, x of -2 gives us a 6. So f of -2 is 6. So same thing that we've kind of done thus far. Now if we do g of f of -2, no, -3, -2, we already know by solving this that f of -2 is 6, right? So we replace it and we find g of 6. So now we're going to move towards this table because this table gives us the output for the function g. So we know that the input is 6. So we're going to find 6 on our input side, t, right? G of t, g of the input t. And you'll see that the output is 11. So this would equal 11. Okay? Let's try f of g of -2. So we need to figure this one out first. So what is g of negative 2? What is g of t? The more I write over this, the uglier and less comprehensible it looks. So what is the output of g when the input is negative 2? We look on our table, we see that it's negative 4. So we can replace this with negative 4. So now we're looking for f of negative 4. So now that we're looking at the f function, we're going to look at the f table. What is the output of the function f when the input is negative 4? And that's going to be a 16. Okay, so same approach for the rest of them. I'm really hoping I can get through the rest of the study guide without a cough attack. Okay. So we have the area of a circle determined by a equals pi r squared, where r is the radius. And then we have c, which is the circumference, is 2 pi r. So the first one is define a function f. Okay, we have f as our name that determines the radius in terms of the circumference. So let's find, so which of these two are we going to use? We're going to use this one because it has a C and it has an R, and those are the two things that we need for this. So really we just need to perform some algebra gymnastics. We want to get R by itself because we're defining R. So we're just going to divide both sides by 2 pi. And that's it. C over 2 pi. Okay, C over 2 pi equals R. F of C outputs R. And our only variable is C. Because remember, pi is just a constant. Okay, I'm back. I'm prepared. As I start coughing again, I don't know why. Okay. So we figured that one out. So now it wants a function. Oh my god. I got this, guys. Hold on. We want a function g that gives the area of a circle A in terms of the circumference. Now, we want to use this one, right? Because it gives us A, but it's in terms of R. But we know that R is equal to C over 2 pi. So wherever we see R, we're going to plug in C over 2 pi because it's the same thing. All right. Oof. Cannot wait for this cough, sickness thing that I have going on to be just out of my system. I'm so sorry. Okay. Number 15. So Farmer Man has a rectangular farm and he has 1,200 feet of fence to use. and he wants the biggest area possible. So it's saying, what is the width of the field if the length of the field is 150 feet? So length and width, right? So we know this is kind of like our perimeter, right? We have 1,200 feet of fence to enclose his whole farm or field or whatever. So this is like the perimeter. So this is a length, this is the length, width, and width, right? So you can say perimeter is equal to L plus L plus W plus W, or 2L plus 2W, right? Would you agree with that? L, W, L, W, L, W, L, W. 2 L's and 2 W's give us our perimeter. So we want to know what the width of the field is when the length is 150. So now that we know this, we can just plug it in, right? So we know our length is 150, so we're going to plug that in. And we're solving for width. And we know that our perimeter is 1,200 feet because that's all he has to work with, right? So 1,200 equals 300 plus 2 TW. Nope, divided by 2 to get the W by itself. So we get the width to be 450. Okay. Okay. What is the width of the field if the length is 302.61 feet? Okay, don't let that freak you out. It's the same exact thing. We know that our perimeter is 1,200. We know that our length is 302.61, and then we just solve for W as we did before. So, define a function k that determines the length of the fence in terms of the width of the fence, given the total amount of fence is 1,200 feet. So it's saying we know that the perimeter is going to be 1,200, right? We still have 2 lengths and 2 widths. However, this is saying we want a function k that defines the length, or determines the length, right, in terms of the width. So we want to get L by itself. So let's subtract 2W from both sides. This is L's buddy, so we won't get rid of it till last. Minus 2W equals 2L. And then we're going to divide that by 2. Leaving us with and that could be simplified. Okay. The next question wants the area. So let's give us some space here real quick. Okay, define a function f that expresses the area as a function of the width, right? So now the area is length times width, right? But we want to get rid of this L. And we just want to use W. Luckily, we found L in terms of W, right? So we can replace L with something that's equal to it. We know that this equals L, so there's no reason why we can't just replace it with that. Times W, because that's equal to L, right? So we would say F of W equals 1200 minus 2W over 2 times W. And like I said, you can simplify that further, but we're not going to do that right now. Okay, we're almost there, guys. So find F inverse of -2. So y equals 3 over 2x minus 5. So what we're going to do, F inverse, the input is actually the output of the original function. So instead of plugging in -2 for x, we're going to inverse it. We're going to turn it inside out, and we're going to plug it in to y. Add 5 to both sides. And you can either just do multiply it by 2, divide by 3, giving you x to be 2. So same thing with f of 2, f of x equals 2x plus 7. F inverse of -2 is we're looking for the x when f of x is -2, right? We switch the inputs and the outputs. So 2x plus 7, subtract the 7, divided by 2. Okay. All right, and we have reached the last one. So f of x equals 6 minus x. G of x equals x squared plus 9. So we want to write the rule for m, meaning the function m, if m of x equals g of f of x. So, same thing as before, let's figure out what f of x is. F of x is 6 minus x. So now we're finding g of 6 minus x. So wherever we see an x, we're going to replace it with a 6 minus x. So we see an x, so we're going to put 6 minus x, and we're going to square it, plus 9. Now, what I don't want you to do is do 6 squared minus x squared, or 36 minus x squared. Don't do it. Why? So x squared means x times x, right? 3 squared means 3 times 3. So 6 minus x squared means 6 minus x times 6 minus x. So we're going to have to FOIL it. First, 6 times 6 is 36. Outer, 6 times -x is -6x. Inner, -x times 6 is -6x. Last, -x times -x is +x squared. So 6 minus x squared, 6 minus x, all of that squared is equal to x squared minus 12x, right? -6x minus 6x is -12x plus 36, right? And then we're going to add that 9 that's left over. So m of x is equal to x squared minus 12x. 36 plus 9 is going to be 45. And that's our answer for that one. Erase, 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 erase. Write the rule for n if n of x is equal to f of g of x. So same thing. First we need to figure out what's in here. So g of x is x squared plus 9. So wherever we see an x, we're going to replace it with this. So that means n of x equals, we're going to plug in x squared plus 9 into the function x. So 6 minus our input being x squared plus 9. So know that x squared plus 9 is our input, so we had to put the whole thing in parentheses. So 6 minus x squared minus 9. So n of x equals, let's see, negative x squared. 6 minus 9 is negative 3. It's supposed to be a little 2. Okay. All right. I know that last bit was rushed, but I really hope that this kind of helped you guys a little bit. Okay. Good luck on the test. You totally got this. Bye.